Hello, EFR 516 students. What we're going to do is we're going to work on assignment number 3, example statistical significance tests. And again, there's an actual assignment. This is the example. So the first one says run a non-directional independent samples t-test with the below data. Use per comparison alpha, page 98 of the text, type meaning type 1 error rate of 0.05. Write up your result statements for the test, the APA. And so we'll go ahead and do that. Now I've included a data set with this in it. So notice dependent variable 0301. So we'll go to the data set. So when we're looking at the data set for both of the problems, note 1 and 2. So this is the first one. So we want to run an independent sample t-test. As we see, here's the first group of 1s, and here's the second group of 2. So we're going to go analyze, compare means, independent samples t-test. Now, the dependent variable is the test variable. The independent variable is the grouping variable. So I bump it over. Then I need to click in there and define groups. So I can click here and define groups. So as I see, my groups are labeled 1 and 2. Now they don't have to be. They can label something else, but it just happens they're 1 and 2. Say continue. I'm going to go ahead and paste first, and that's going to paste it to my syntax window. Now my syntax window is already open, so I don't see it, so I got to go down to the SPSS symbol. I'll click on that, and then that'll show my syntax window. So here's my test. I'm going to go ahead and block it and hit the green arrow to run it. Okay, so here's the table I'm interested in. So the means of group 1 were 4, the means of group 2 was 9.1. But this is the table, so I'm going to click on it. I'm going to go right mouse and I'm going to say copy special. And I'm going to copy as a meta file. So I'm going to uncheck all these others and copy the meta file. So I'm going to say OK. So copy special, OK. And then I'm going to bring that over to my assignment. I'm going to paste it in there. Okay, so then I ask you to write the APA statement for it. So this is a t-test. We'll use equal variance assumed. So this is a t-test. So now sometimes you get a capital T when you're starting here. Don't worry about it. So it's a T with 18 degrees of freedom. My degrees of freedom are right here, 18. And its value, what's the value of the T, equals, well, we look at there, minus 3.043. So minus 3.043, comma, is the P greater than or less than 0.05? So we're doing a non-directional test. So this is my p-value. So I got 0.007. So I see that it's less than 0.05. That indicates that it's statistically significant, meaning that we believe the two groups are different, have different populations. Okay, so that's what we're doing for the first one. And we'll go ahead and move to the second one. Okay, it says do a non-directional independent sample t-test. Same thing as we just did. Okay, so we're going to come back to our analysis. The table, again, I'm providing SPSS for you. Here's the data we want to use. So I'm going to go analyze, compare means, independent sample t. I'm going to reset it, and then I'm going to bump over 2. So I'm going to define my groups. So again, they're 1 and 2. And I'll say continue, and then I'll paste again. So pasting has enormous advantages that you have a record of your syntax. So again, I need to go there. So I'm going to go down on the SPSS symbol on the bottom of my desktop. I'm going to block that, and I'm going to run that. Okay, so here's my results. So I'm going to go ahead and copy that over. It's a meta file. And I'll paste it right in here. And then I need to write up the APA. So my APA statement would be t-test with 18 degrees of freedom, just like before. Its value of the, here, hold on. Looks like I copied my last test. So let me delete that. Let me go over and make sure I've copied the correct one. So I'm going to go back. And here's the one I need to correct right over here. So I'll copy this one. Make sure I highlight this one. So it's highlighted here. See the red arrow? No, I got the right one. Paste that in there. So again, 18 degrees of freedom, its value is right here, minus 2.318, comma, P what? P, again, is 0.032, less than 0.05? Yes, it is. Less than 0.05. So by itself, an individual comparison-wise, it's statistically significant. Now, I'm going to go ahead and bring both these tables down to the next problem. So I'm just going to grab that down. And I'm going to paste it in here. And then I'm going to go grab this one right here. So I'm going to put these both here for this one right here. Okay, so now assume that you want to control your experiment-wise alpha at 0.05 for the two tests above, right? So the two tests we just did. Reevaluate if they are statistically significant or not using Bonferroni correction per comparison. And this is on page 98, 3.8. So here's the comparison we need to make. So we're going to control the overall family-wise, experiment-wise error. Again, sometimes it's called family-wise, at 0.05. So we need to divide it by the number of tests we did. We did 2. So now our new alpha, our P less than, for the experiment-wise, for each individual comparison should be 0.025. So if we look at our APA statements, grab this one. For the first one, and then I'll grab the second one. Now the question is our P less than 0.025? So, and when we look at that, the first one is less than 0.025, so that hasn't changed, right? Our sig two-tailed was 0.007, but our second one was 0.032, which is not less than 0.025. So it's greater than 0.025. So we've controlled the experiment here at the experiment-wise of 0.05, but that left our comparison-wise different. So this one we reject H naught. And this one we fail to reject. Okay, so that's an example of controlling at experiment-wise using the Bonferroni correction. Okay, so now when we come down to number 4, I want you to go to G power, and here's the connections for it. So, and these should be very safe. Shouldn't be any problem. These are well known. You can go to the Kent State site first, but then it'll bring you to the actual where you're going to download the file. So I want you to do a power calculation. So calculate the total sample size you'd need to find an effect size of 0.6 with alpha error probability, type 1 error rate of 0.05, power of 0.9 for a 2 independent samples t-test. Use allocation ratio of 1. So when we look at this, when we pull this up, it'll look like this. So I'll pull my power value up here. And again, once you download this, it'll look like this. it'll just become part of your tags. So, okay, so I want an effect size of 0.6. Now when we click on this, we see that we have Cohen's effect sizes of small, medium, and large. And then we have type 1 error rate of 0.05. Our power is set at 90%, and a ratio of meaning equal sample size in each group. Now it's important, we want the mean differences 2 independent sample t's. So we have to select this independent means, 2 independent means, 2 groups. Okay, and once I've done that, I can go ahead and ask it to calculate. So here's my calculation. So for the assignment, I need 64 in each group, or a total of 128 is my sample size. This is very important. You often see this in when you're calculating grants, the funding, NSF or education statistics. They'll require that you do a power sample size calculation for your main question. So this is the answer I'm looking for. The answer would be 128. So go ahead and do that calculation, and this concludes the example. Now you got an actual assignment to do. Thank you.